Description. Introduction. As technology moved towards digital era, RDSO developed digital axle counters in 2003 as per Safety Integrity Level 4, which is a higher standard. CEL and RDSO jointly designed single-section digital axle counter SSDAC and introduced in railway working. Features of SSDAC are given below. Designed as per CENELEC standards of Safety Integrity Level 4 SIL 4. Uses microcontrollers. Advantages over UAC. Works on high frequencies of 21 kHz and 23 kHz for better noise immunity. Trackside units are provided without need of central evaluator. Status of section is displayed at both ends by Q-type relay 24 volt 1000 ohms. Works on one pair of quad cable, that is half quad or on OFC. Digital axle counter are compatible with OFC digital microwave communication media. It monitors long track sections up to 20 km or 30 decibel loss at 2 kHz. Trolley suppression track circuit is not required in phase modulation type. Error code display by LEDs on MLB cards and LCD on reset box. System consists of fail-safe features. AC signal processing, clock signal generation, 2 out of 2 decision by microcontroller, opto-isolated output for vital relay readback, checking of health signals in system and withdrawing vital relay drive if found faulty. Real-time processing of events. Cycle time less than 100 microseconds. Diagnostic features include description and advantages.
Axle counter is a signaling equipment for use in Indian Railways to monitor the presence of a train on a specified track section. This track section can be platform lines, main lines of station yard, or block section between two stations. The single section digital axle counter works on the principle of counting of axles of the passing train at the limits of the section and indicates the occupancy or clear status of the section to the operating staff. The latest version of axle counters are designed using microcontroller with embedded software and are capable of working on both copper and optical fiber cables. Now let us take a look at the evolution of axle counters at CEL. CEL and RDSO have jointly developed a single-section digital axle counter using a microcontroller. The SSDAC system was designed to RDSO specification number RDSO/SPN/177/2003 version 1 and International Safety Standard CENELEC Safety Integrity Level 4. The latest model has been designed to RDSO specification number RDSO SPN 177/2005 version 2 with error display facility in the reset box. The main advantages of single section digital axle counter system over analog axle counters are: the SSDAC uses high-frequency axle detectors, that is 21 kHz and 23 kHz, for higher noise immunity to traction current. It has track-side electronic counting unit that eliminates the need for separate evaluator. It has web-mounted type axle detectors for easy installation and maintenance. 4. The system has track clear relay output provided at both ends. 5. System works on one pair, that is half quad of cable. 6. The system has lower power consumption. And 7. It can monitor long sections up to 20 kilometers. The SSDAC is designed and supplied in two different Model 1. Single section digital axle counter amplitude modulation type Model DACF 700A and DACF 710A. Single section digital axle counter phase reversal type Model DACF 700AP 710P.
Architecture. This system is divided under three heads: outdoor equipments, indoor equipments, communication between outdoor equipments of both ends. Indoor and outdoor equipments. Outdoor equipments consists of two pairs of axle detectors with deflectors, one at each end, that is entry and exit ends. Each end has two transmitter coils and two receiver coils with cables laid in HDPE pipes at each end. One pair of location box with shelf and termination board that houses the following at each end: trackside SSDAC electronic units, one relay box consisting VR and PR relays, one surge voltage protection device, earth and earth connections at each end, trolley suppression track circuit at each end where the SSDAC amplitude modulation version is installed. Indoor equipments at each end consists of reset box, power supply arrangement, surge voltage protection device, earth and its connections, VPR, PPR relays in relay room. Communication. Quad or OFC cable connects entry and exit end SSDAC unit. Signaling cable connects outdoor equipment and relay room. Relay room and SM's reset box. Track device or axle detector. Each detection point comprises of two numbers of transmitter coils and two numbers of receiver coils. Receiver set always connected to inner side of rail. Transmitter coils are always connected to outside of the rail. At entry coils are named as TX1, RX1 and TX2, RX2. At exit end coils are named as TX3, RX3 and TX4, RX4. TX1 and TX3 are fed with 21 kHz. RX1 and RX3 get induced voltages of the signal. TX2 and TX4 are fed with 23 kHz. RX2 and RX4 get induced voltages of the signal. Card and frequency. Single conditioner card number 1 feeds 21 kHz to TX1 at entry end and to TX3 at exit end. Card and frequency. Single controller card number 2 feeds 23 kHz to TX2 at entry end and to TX4 at exit end. Wheel detection. Without wheel, induced voltage in receiver coils is at phase lag of 180 degree with respect to reference signal of transmitter coils. When wheel flange passes between transmitter coil and receiver coil, there is a dip in the induced voltage in receiver coil and also an increase in phase difference from 180 degree up to 360 degree, which is detected and processed as wheel pulse. Installation of axle detectors. Precautions before selection of spot for installation of axle detectors. In main lines, loop lines axle detector is to be fixed at both ends of berthing portion. For use in BPAC, axle detector is to be installed after the advanced starter signal of one station and home signal of the other station on double line section and opposite direction advanced starter at other station on single line section. To be fixed on same rail, either on left rail or right rail at both ends, or else it will result in both counts treated as in or out. Avoid installation on curved track. If amplitude modulation type of unit is to be installed, trolley protection track circuit shall be more than 5 rail length for single line and axle detectors are to be fixed at the center. 3 rail lengths for double line and axle detectors are to be fixed at 33 meters away from block joint in the direction of train movement. Proper earthing arrangement to be done near high voltage and feeder stations. Precautions before installation of axle detectors. Ensure that the distance between two axle detectors of two SSDAC systems is at least greater than 2 meters to avoid mutual interference. Ensure that axle detectors is fixed in clear spacing of 400 millimeters between the two sleepers. Ensure the size of rail. Height of 90-pound rail is equal to 142.55 millimeters. Height of 52 kilogram rail is equal to 156 millimeters. Height of 60 kilogram rail is equal to 172 millimeters. Ensure that the condition of worn out of the rail is within the limit. For 60 kilogram less than 13 millimeters. For 52 kilogram less than 8 millimeters. For 90 pound less than 5 millimeters. Ensure that embossing of rail is not covered by axle detector. Ensure that distance between location box and axle detector is less than 10 meters as TX coil cable and RX coil cable are provided with 10 meters in length. Ensure that these TX cable and RX cable are directly connected in location box without forming any loop. Ensure that these cables are laid in high density polyethylene pipe HDPE pipes of diameter 40 millimeters for the safety of cables. Ensure that HDPE pipes are laid at depth of not less than 1 meter from the bottom of the rail. Ensure that TX coil cable and RX coil cable are laid separately in different HDPE pipes which are separated by minimum 400 millimeters. Procedure of installing axle detector. Keep the zig on the rail and fix it, then mark the 3 holes. Punch the markings. Ensure that for 52 kg and 60 kg, 88 mm marking from the top of rail is used, and for 90 pound rail, 86 mm marking from the top of the rail is used. Use ratchet or drill machine for drilling the holes. First use drill bit of size 6 mm or 8 mm and then drill bit of size 14 mm to drill the web. Verify the position of holes by fixing the jig with clamp properly. Now fix the transmitter coil at outer side of rail and then receiver coil at inner side of the rail. For fixing of TX coil and RX coil on web of rail, use nuts, bolts and spring washers of M12 by 100 mm. Use 88 nanometers stock ranges for tightening the nuts. Ensure that direction of extreme nuts is different from center nut. Use 3 nuts of M12 into 100 mm for tightening. Ensure that hose pipe of coils are not buried in ballast to avoid any damage. Put both TX coils in one pipe and then RX coils cables in another pipe. Ensure that deflectors are connected at a minimum distance of 30 cm to 40 cm from coils and also in next sleeper space. Ensure that the height of the deflector is not installation of track device or axle detector. Precautions for installation of axle detectors.
One set of SSDAC consists of the outdoor unit and the indoor unit. The outdoor unit consists of axle detectors comprising of one TX housing and one RX housing, track side electronic counting unit, that is entry unit, and exit unit, one number each. The vital relay box and the surge voltage protection device. The indoor unit consists of the reset box and their supportive equipments. Now we will discuss the installation of the track side equipments of the single section digital axle counter. Before discussing the steps involved in the installation of the outdoor equipment of the SSDAC, let's take a look at some important points which should be kept in mind for installing the axle detectors. 1. Ensure that the axle detectors are installed after the advanced starter signal post. And the home signal post on UP and DN lines for use as BPAC on double line section. Ensure that the axle detectors are installed after the advanced starter signal post of both the stations for use as BPAC on single line section. In main lines, loop lines, yard area, the axle detectors should be fixed just after the starter signal post of each line under monitoring of SSDAC. Ensure that the axle detectors are fixed on the same rail, that is, either on left side or the right side of the track at both the entry end and the exit end. The axle detectors should not be installed with the entry unit on left rail and exit unit on the right rail of the track at entry and exit of the section. This will result in both units being counted as in count or out count. 6. While selecting the site for axle detectors near high voltage SSPs and feeder stations, ensure that proper care is taken as per railway procedures of installation of quad cables and proper earthing arrangement. 7. Avoid installation of axle detectors on curved tracks or on bends. For amplitude modulation type model only, applicable for DACF 700A/DACF 710A. Ensure that the length of the trolley protection circuit in case of single line 5 RL and in case of double line 3 RL is maintained. And lastly, while fixing of axle detectors in a single line, ensure that it is fixed in the center of 5 RL, whereas in case of double line it should be fixed at 33 meters from block joint in the direction of the train movement. In the installation of SSDAC outdoor equipment, we shall first discuss the installation of axle detectors. The axle detector unit consists of web mounting type transmitter coils or the TX coils, web mounting type receiver coils or the RX coils, and the rail deflector bracket assembly. Now let's take a look at some precautions which needs to be taken before installing the axle detector. 1. Ensure that the separation between axle detectors of two SSDAC systems should be at least 2 meters to avoid mutual interference. Ensure that the axle detectors are fixed in the clear spacing of 400 mm between the two sleepers. Three. Ensure the size of the rail is 90 R or 52 kg or 60 kgs only. 4. Ensure that the condition of worn out of rail is well within the limits. For 60 kgs, it should be less than 13 millimeters. For 52 kgs, it should be less than 8 millimeters. For 90 R, it should be less than 5 millimeters from the top. Number 5. Ensure that the embossing of rail is never covered by axle detectors. Number 6. Ensure that the distance between the location boxes and the axle detectors is less than 10 meters, as TX coil and RX coil cables are provided with 10-meter cables. Number 7. Ensure that these TX coil and RX coil cables are directly taken to the location box without forming any loop. Number 8. Ensure that these cables are laid in high density polyethylene, that is HDPE pipes of 40 mm in diameter for the safety of cables. Number 9. Ensure that the HDPE pipes are laid at a depth of not less than 1 meter from the bottom of the rail. And lastly, ensure that the TX coil and RX coil cables should run separately in different HDPE pipes at a minimum separation of 400 millimeters.
Installation of axle detectors.
Installation of axle detectors. Firstly, fix the marking jig from the top of the rail and fix it to the rail with a clamp. Then, using the marking jig, make the marking for 3 holes with a punch on the web of rail according to the rail size. Ensure that for the 60 kg and 52 kg rail, marking of 88 mm is used, and for 90 R, marking of 86 mm is used as given in the marking jig. Incorrect marking of 60 kg and 52 kg in 90 R rail will result in miscounting. Use ratchet or drilling machine for drilling the hole. First, for drilling the hole, use drill bit of size 6 mm or 8 mm. Then use drill bit of 14 mm size for drilling of web as required. Drilling is done manually, but it can also be done using an electric drill machine like this. Verify the position of holes by fixing the marking jig with clamp properly. Now fix the transmitter coil assembly, that is 21 kHz and 23 kHz, on the outer side of the rail. Then fix the receiver coil assembly, that is 21 kHz and 23 kHz, on the inner side of the rail. To fix the TX coil housing and RX coil housing on the web of rail, use bolts, nuts and spring washers of M12 by 100 millimeters. Use 88 Newton meters torque wrench to tighten the nuts and the bolts. Also ensure that the direction of bolts of extreme ends is different from the bolt at the center. Use 3 numbers of check nuts M12 into 100 mm to tighten the axle detectors. Make sure to keep the hose pipe attached to the TX coil and RX coil housing in curve and not to be pressed in the ballast. This curve or loop will help in reducing the tension or damage of the housing during vibration. Now take the TX coil cables marked with 21 kHz and 23 kHz together in one HDPE pipe to the location box. Similarly, take both RX coils marked with 21 kHz and 23 kHz together in separate HDPE pipe to the location box.
Cue for installation of deflectors.
First, take a look at some precautions which need to be taken while installing the rail deflector bracket assembly. Ensure that the deflector is positioned 30 to 40 centimeters away from the TX-RX coils and are positioned in the neck sleeper. Ensure that the height of the deflector is not higher than the rail top. While installing the rail deflector, mount the rail deflector plates on both sides of the track fittings. Fix the deflector plates in front of the axle detectors. This will ensure that the fittings are protected against any damage from the hanging parts of a moving train. Fix the deflector clamps at the bottom of the rail with the deflector plate using bolts and nuts on each side.
Of location box and surge device.
About the installation of the location box and its terminations. While installing the location box and its terminations, install the location box as close as possible to the axle detectors, that is within 10 meters. Ensure that one shelf is provided in the location box to place the SSDAC counting unit, vital relay box, and the surge voltage protection device unit. The VR relay box consists of dual relay, that is the VR relay and the PR relay of Q type, 24 volts and 1000 ohms. Hence, no external relay is required in the location box. In older version of VR relay box, only VR relay was provided in the VR box. The PR relay is mounted in the location box. The incoming and the outgoing cables from axle detectors, SSDAC unit, modem and the cable going to the cables and the axle detector cables are terminated on the DIN rail using spring cage type terminals. Ensure that only quad cable /PIJF twisted pair telecom cable is used between the field units. Ensure that proper pair of quad cable is used for connecting modem signal. Ensure the connections to these terminals as per the wiring details are provided by the installation manual. Ensure that the insulation resistance of quad cable is greater than or equal to 10 mega ohms. Ensure that the loop resistance of designated pair should not exceed 56 ohms per kilometer. Ensure that the attenuation loss measured at 2 kHz is not greater than 30 dB for full length of cable. Ensure that near end crosstalk and far end crosstalk shall be better than 55 dB for quad cable. Ensure that the unused pair of quad cable is cut in such a way that none of the conductors remain exposed. And finally, ensure that the spiraling of conductor before termination is avoided. Ensure that the earthing is proper. All the earth connections should be intact and the soldered points should be in proper condition. Remove the top cover of the SVPD unit. Fix the surge voltage protection device unit or the SVPD unit on the same wooden hilum or the NFTC plank firmly inside the location box along with other units using nuts and bolts. Connect the wiring to the surge protection device as per the wiring diagram provided. Provide the earthing connection by use of earthing cable supplied separately with the SVPD unit.
SSDAC unit. The SSDAC unit of the digital axle counter system is manufactured in a 3U height and 42T width desktop enclosure. The system comprises of 8 plug-in cards. All the cards are of extended single Euro size. 220 mm into 100 mm that plugs into a motherboard in the cards must be inserted in the order of card 1 to 8 from left to right in the sub-rack. The various dimensions of the system are as follows. Width is equal to 300 mm 42T. Height is equal to 133 mm 3U. Depth is equal to 300 mm. Entry-exit address settings. To permit communication only between concerned pairs, each set is given address setting of 8-bit address using a dip switch located on the rear side of each unit. Manufacturers presets every pair as 0203. If more than one line of a station is provided with SSDAC units, other pairs are to be given subsequent numbers such as 0405 as per table given. Now details of each card is given below. This unit consists of signal conditioner cards, micro logic boards, event logger cards, modem cards, relay driver cards, DC-DC converter, vital relay, video for SSDAC unit.
SSDAC unit of the digital axle counter system is manufactured in a 3U height and a 42T width desktop enclosure. The system comprises of 8 plug-in modules. All the cards are of extended single Euro size, that is 220mm into 100mm, that plugs into a motherboard in the sub-rack. This diagram shows the front view of the system and the position of the PCBs, and this diagram shows the rear view of the system. The cards must be inserted from card 1 to 8, starting from left within the sub-rack.
One signal conditioner card 1 and card number 2 signal conditioner card 2. Card number 1 signal conditioner card 1. Main functions of this card are: generates 21 kHz signal and feeds TX1 coil at end, TX3 at other end. Demodulates of received modulated signals from RX coil. Generates valid train pulse with supervisory levels. Forwards the valid train pulse to MLB card. Indications provided on card number 1. OSC OK, green LED. LD OK, green LED lit when level of received signal is OK. Pulse OK, green LED. This LED changes between off and on during train movement, and it will not lit if polarity of RX cable is reversed. TPCON, green LED indication for trolley suppression track circuit. Card number 2, signal conditioner card 2. Generates 23 kHz signal and feeds TX2 coil at one end, TX4 at the other end. Other functions and indications are same as in card number 1. MS couplers. MS1 7-pin coupler. MS2 5-pin coupler. Voltage on monitoring socket. Microcontroller logic board 1 and card number 4 microcontroller logic board 2. Two cards are used for 2 out of 2 logic. Both are identical and interchangeable. These cards use microcontrollers. The salient features of the card are as follows. RS-232C compatible serial port for modem connectivity. Flash ROM for program storage. Parallel ports for address and mode input. Pulse inputs and vital relay output and relay readback. LED display. A block of 8 LED indicators for count progress and error display. 2 independent LED indicators for section status. Main function of these cards are given below. Monitor and receive pulse signals from SCC cards. Wheel counting. Train direction checking. Code message packets for transmission to remote SSDAC. Decode message packets received from the remote SSDAC. Output pulse signals to other MLB through modem. Determine the number of axles in the section. Control and supervise the status of vital relay. Indicate the status of the section for clear or occupy. LED check. Communication link failure. Presence of various cards. Each MLB keeps track of 3 different counts given below. Primary count, its own wheel count. Secondary count, wheel count of second microcontroller. Remote count, count values of remote SSDAC unit. Improvement in software. Software modified version S006 Data refresh duration reduced from 1.8 seconds to zero point 0.8 seconds with status updating every zero point 0.8 seconds called update count packet. When the SSDAC detects the first train wheel entering the track section, it sends a count change packet to the remote SSDAC. Primary count for the original pulse inputs and secondary counts for the filtered pulse inputs received from the other MLB. Counting of wheels. Pulse 1, 21 kHz and Pulse 2, 23 kHz signals are normally high and go low when a wheel passes over the respective RX coil. Sequence of Pulse 1, 21 kHz and Pulse 2, 23 kHz signals gives the direction of movement of train. If Pulse 1, 21 kHz goes low before Pulse 2, 23 kHz then wheel is moving from RX1 coil to RX2 coil. In Pulse 2, 23 kHz goes low before Pulse 1, 21 kHz then wheel is moving from RX2 coil to RX1 coil. This scheme of wheel counting is implemented in software using a state machine approach. Change in pulse inputs result in change of state. As a matter of convention for counting, a wheel moving from 21 kHz to 23 kHz is taken as incrementing and vice versa is taken as decrementing. Same convention is applied at both ends. Please note the following for clear understanding. Incrementing count at entry end or decrementing count at exit end is equivalent to in count. Incrementing count at exit end or decrementing count at entry end is equivalent to out count. Wheel count is incremented or decremented only when the wheel completely crosses the detection point. Entry and exit end units are stamped accordingly and are not to be interchanged. Basic states of systems are as below. Preparatory reset. Reset applied. Clear. Section clear. Occupied. Section occupied. Disturbed. Error in the system. Indications provided on these MLB cards which are given below. 8 LED block, all red LEDs, normally off, glows when error appears. These errors are discussed in troubleshooting topic. Clear, green LED, glows for clear condition. Occupied, red LED, glows for occupied condition. No measuring socket is provided. 5. Event logger card. Event logger card is designed to capture and store important signals from the remote and local SSDAC units. The stored data can be downloaded from the event logger card for the purpose of analyzing the events occurring during the operations of the SSDAC. The data can be analyzed with the help of CEL data analyzer software. Indications provided on event logger card are: run, green LED. It blinks continuously, normal working of the event logger card. Log, green LED. Every 2 minutes data is being logged into the flash memory of when downloaded is complete. Download, green LED. This LED is on when data is being downloaded from the flash memory of the card. Following signals are captured by the event logger card. Card removal information. Serial packets from MLB1 local unit, MLB2 local unit, remote unit, communication failure and composite information from MLB1 and MLB2. Event logger card has a rapid processor and 2 MB flash memory to store packets. The data is initially stored in the buffer and subsequently transferred to flash memory every 2 minutes. Normally, 4096 pages of the data can be stored in flash memory. The overflow of the data is stored by overwriting existing pages of the flash memory starting from 0 page onwards. This activity of the overwriting memory is known as circulation of flash memory. Features of modem card. AGC, automatic gain controls provided in receiver and transmitter path. Reset command is active only for 200 milliseconds to 10 seconds. V21 modem is used for communication between two units of SSDAC, originator, entry unit and answerer, exit unit. Digital packets generated by MLB cards are sent to remote unit on a pair of cable. Structure is as shown in picture. Serial input-output multiplexer is used to select the microcontroller card that will communicate with the modem on the remote unit. SSDAC reset circuit is included in the modem card, wherein the reset voltage window 42 volt to 52 volt and reset timing window between 0.2 and 10 seconds functions has been provided. Reset command will not respond for the cases outside these windows. Modem card is V21 type, 2 wires in single section digital accel counter. This card interfaces with serial RS-232 C port of both microcontroller logic block cards. It multiplexes the two RS-232 inputs and selects one of the two channels and provides signal conversion from digital to analog and vice versa as per CCITT V21 standard. The board uses OKI FSK full duplex modem IC. 300 baud rate. Originator, entry unit and answerer, exit unit for V21 selected. Communication protocol. The communication protocol comprises of following packets: power on and reset packets J and R, count change packet C, count update packet U, power on and reset packets J and R. The reset packets are of two types, J packet and R packet. After power on to the system, though SSDAC units are energized, vital relay will be in drop condition till reset command is given from SM's reset box. After applying the reset from SM's reset box, the resetting takes place in the units and SSDAC performs the self-test. After successfully completing the self-test, the local unit generates the J packet and sends to the remote unit and vice versa. This reset packet includes the system status. The R packet is received from the remote unit against the transmitted J packet from local unit. Then both units go into handshaking mode and come to preparatory reset condition. The SSDAC keeps sending the J packet at regular intervals till R packet is received from the other SSDAC. Count change packet C. This packet is sent by the SSDAC if the count status changes from matching to mismatching. This normally happens after the wheel count from first wheel of train is detected in clear state. This packet is basically used to warn the remote SSDAC that a train is entering the section from this end and that the remote SSDAC to change the status to occupied. Count update packet U. The count update packet is sent by an SSDAC to remote SSDAC for every 800 milliseconds. This packet carries the status of wheel count and health to the remote SSDAC and vice versa. Indications on modem card. TX green LED continuous flashing to indicate modem working to transmit signal from local unit. RX green LED continuously flashing when signal is received from the remote unit. Mode. Green LED normally off. When system is made to restart, LED glows and again goes low when system enters self-test after successful reset. CD, green LED, lists to show carrier of modem signal available. MS couplers MS4 and MS5. The two MLB cards send the digital packet information to the modem card through the Axle counter motherboard. The modem card converts the digital packets to analog signals for transmission. The analog signal from modem card through Euro connector is available at 4-pin connector P5 on motherboard and then connected to a 4-pin MS circular connector on the back plate. The modem is connected with remote SSDAC unit via station by means of two-wire 0.9 mm diameter quad cable in block section for track circuit. The voice channel on OFC cable can also be used for connecting SSDAC units between two stations for block working. The resetting of unit is provided through C and D pins of MS coupler 4. The 48-volt DC is available at these pins when reset is applied by SM from SM's reset box. The pin configuration of 4-pin MS connector 4 is given in table in next page. Switch settings in modem card. The modem card transmits and receives the digital packet information from one counting unit to the other. The modem has been set in originator mode for entry unit and in answer mode for exit unit as default. The selection of dip switch SW2 and SW3 is given below. The dip switch can be accessed by removing the card shield of modem card. Relay driver card. The relay driver card provides the 24-volt DC output required for driving VR and PR relay to pick up. There is no adjustment required in this card. Indications provided on relay drive card. MLB 1 clear, green LED. Indication will glow after counts are balanced in the section. This LED indication becomes off when the section is occupied. MLB 1 clock, green LED. LED flashes when the section is clear and indicates the presence of clock from MLB 1 card after the counts are balanced. This indication is off or on depending on the interruption of clock from MLB 1 when the section is occupied by a train. MLB 2 clear, green LED. Indication will glow after counts are balanced in the section. This LED indications becomes off when the section is occupied. MLB 2 clock, green LED. LED flashes when section is clear and indicates the presence of clock from MLB 2 card after the counts are balanced. This indication is off or on depending on the interruption of clock from MLB 2 when the section is occupied by a train. Relay drive, green LED. The LED glows when the relay drive output is present. LED indicates the presence of relay drive output, 24-volt DC to Q-type relay from relay driver card. This indication is off for section occupied. All the above LEDs are lit for section clear condition. On R1 and R2 of this relay, voltage should be more than 20-volt DC when section is clear and should not be more than 2-volt DC when section is occupied. The main functions of the card are dual clock checking circuit, opto isolator circuit, vital relay drive output, preparatory reset PR relay drive output, MS coupler, MS3. It is a 6-pin coupler and details are given in table.